Good morning, students. Let us start with the today's session. So today we are going to discuss the mechanical properties of fluids. So now ivattu mechanical properties of fluids lesson anna discuss ಮಾಡ್ತಾ ಇದೀವಿ. So in this lesson again first ನಾವು ಇಲ್ಲಿ ಕೆಲವೊಂದು formulas ಅನ್ನ ಮತ್ತೆ definitions and the laws, some principles that we will discuss in the beginning. Then after that we will discuss about the question answers. Okay. So see here, mechanical properties of fluids. So what do you mean by fluids? Fluids ಅಂತಂದ್ರೆ ಏನು ಮೊದಲು ನಮಗೆ ಅದು ಗೊತ್ತಿರಬೇಕು. So fluids are the substances which can flow. ಹೌದಾ? So fluids ಅಂತಂದ್ರೆ ಏನು? These are the substances which can flow, that is called as fluids here. So in the fluids we have liquids and the gases. So liquids ಮತ್ತೆ gases ಅನ್ನ ನಾವು example ಆಗಿ consider ಮಾಡಬಹುದು. Right? So here we are defining the pressure here. What do you mean by pressure? That the thrust experienced per unit area of the surface of a liquid at rest is called as pressure. So you can see the pressure is given as the force per unit area, that is F divided by A. So in the CGS unit, what is the unit of this pressure? The force is expressed in terms of Newton and the area is expressed in terms of meter square. So in SI system, it will be Newton per meter square, and this Newton per meter square is called as Pascal. And in CGS unit, this is called as dyne per centimeter square. Okay. Then here we have the relation between 1 Pascal and 1 Newton per meter square. So that is 1 Pascal is equal to 1 Newton per meter square. So this is the expression for force. This is the basic expression. Iden expression nodta idire, idu basic expression agutte. So namdu pressure iddu mattond formula ide. Yavaga when the pressure of the liquid we are measuring based on the height. So yavaga liquids anna, for example, one container alli tagondaga you can see the different levels we can see there. So the different levels alli ಏನ್ pressure ಆಗುತ್ತೆ, ಏನ್ pressure ಇರುತ್ತೆ ಅಂತನ ನಾವು measure ಮಾಡಬಹುದು. So that pressure is given by, you can see this equation, that is pressure P is equal to rho GH. H ಅಂತಂದ್ರೆ height, ಅಂದ್ರೆ ಯಾವ ಕಂಟೈನರ್ ಅಲ್ಲಿ ಲಿಕ್ವಿಡ್ ಯಾವ ಪಾಯಿಂಟ್ ಗೆ ನೀವು ಮೆಜರ್ ಮಾಡ್ತಾ ಇದೀರಾ ಪ್ರೆಷರ್, ಸೊ ಆ ಹೈಟ್ ಅನ್ನ ನಾವಿಲ್ಲಿ H ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದೀವಿ. ರೋ ಇಸ್ ದಿ ಡೆನ್ಸಿಟಿ ಆಫ್ ದ ಲಿಕ್ವಿಡ್. ನೀವು ಯಾವ ಲಿಕ್ವಿಡ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ, ಅಂದ್ರೆ ವಾಟರ್ ಇದೆ, ಕೆರೋಸಿನ್ ಇದೆ, ಆಯಿಲ್ ಇದೆ. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ದ ಡೆನ್ಸಿಟಿ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಚೇಂಜ್. G is, it is acceleration due to gravity. Okay. So the basic formula for pressure is force per unit area. Then the pressure is also measured as rho GH. So this is the pressure when you are calculating the pressure at different heights of the liquid. Okay. Then here we are defining the law, famous law for the pressure concept, that is called as Pascal's law here. So what is this Pascal's law? The Pascal's law states that, so if you consider ನೀವು ಯಾವುದಾದ್ರೂ ಒಂದು closed container ಅನ್ನ ತಗೊಂಡ್ರೆ, if you consider any one closed container here, so in that closed container if you consider the liquid, so one closed container ಅಲ್ಲಿ liquid ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. When you apply pressure at one particular point, so if you are not understanding that, assume that you have a balloon. So ಆ balloon ಅಲ್ಲಿ ನೀವು air ತುಂಬಿದ್ದೀರಾ. So whatever the pressure you are applying at one point, ನೀವು balloon ಅನ್ನ one point ಅಲ್ಲಿ press ಮಾಡಿದ್ರೆ, you can see that the pressure is exerted at all the sides of the balloon here. So same concept we can apply it for the liquids also. So when the liquid is enclosed in any of the system, okay, so whatever the pressure you are exerting at one particular point, it will be transmitted to all the sides of that vessel. Okay, this is called as Pascal's law. So this Pascal's law is having many applications, like it is used mainly for the hydraulic systems. You might have seen ನೀವು ಇಲ್ಲಿ ಮೆಕ್ಯಾನಿಕಲ್ ಶಾಪ್ಸ್ ಅಲ್ಲೆಲ್ಲ ನೋಡಬಹುದು, that is you see that when they are washing the vehicles, heavy vehicles, either it is a bike or car here, so heavy vehicles ಅನ್ನ ವಾಶ್ ಮಾಡಬೇಕಾದ್ರೆ they will use the hydraulic machines. So ಏನ್ ಮಾಡ್ತಾರೆ, ಒಂದ್ ಕಡೆ ಪ್ರೆಷರ್ ಅಪ್ಲೈ ಮಾಡ್ತಾರೆ, ಇನ್ನೊಂದ್ ಕಡೆ ಏನಾಗುತ್ತೆ, whatever the vehicle is there, that will move in the upward direction. So that is the application of Pascal's law, right? So Pascal's law is given by F1A1 is equal to F2A2. F is force, A is the area of that side you are considering. Then next, so here the pressure, again we have the expression, that is if you consider PA as the atmospheric pressure, then pressure in a liquid at a depth H is given by. So if you consider that is the pressure as atmospheric pressure, what is the pressure acting on the system? So this is given by P is equal to PA plus rho gh. So ನಮ್ಗೆ ಆಲ್ರೆಡಿ ಏನ್ ಗೊತ್ತಿದೆ, ಪ್ರೆಷರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ರೋ ಜಿ ಎಚ್ ಅಂತ ಗೊತ್ತಿದೆ. ಇಲ್ಲಿ ನಾವು ಪಿ ಎ ಅನ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ವಾಟ್ ಇಸ್ ದಿಸ್ ಪಿ ಎ? ಇಟ್ ಇಸ್ ದಿ ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ pressure. Here we study one more pressure, and that is called as gauge pressure. So if gauge pressure anta andre nu, that is the difference between the absolute pressure and the atmospheric pressure. So ನೀವು ಯಾವಾಗ difference of the pressure ತಗೊಂತೀರಾ ಅದನ್ನ ನಾವು gauge pressure ಅಂತ ಹೇಳ್ತೀವಿ. So ಇಲ್ಲಿ ನೀವು absolute pressure is equal to, you can see, ಅಥವಾ gauge pressure is equal to ಏನಾಗುತ್ತೆ ಹೇಳಿ ಇದು equation, gauge pressure is equal to absolute pressure minus atmospheric pressure, right? So this is regarding the pressure at some height. Then the gauge pressure, it is the difference of the pressures. Then the one more point we discussed, that is Pascal's law. Okay, so next here we have the equation of continuity. What is this equation of continuity? So if you consider one pipe alli enadru water flow ಆಗ್ತಾ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. So the same water at different points if you consider, okay, so that whatever the water is there, the velocity of that water, here you can see that according to this equation of continuity, now ಏನಂತ ಹೇಳ್ಬೋದು, there is no fluid source or a sink along the length of the pipe. The mass of the fluid crossing any section of the pipe per unit volume remains constant. ಅಂತಂದ್ರೆ ನೀವೇನಾದ್ರೂ ಒಂದು ಪೈಪ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so if you consider that pipe, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನ್ ಮಾಸ್ ಪರ್ ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್ ಇರುತ್ತೆ, if you consider the different point in the same pipe, the mass per unit volume at that point also it is same. The mass per unit volume at each and every point in that pipe crossing in that pipe, that will be remaining constant. So based on that, ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ, the formula is, that is A1 V1 rho 1 is equal to A2 V2 rho 2. A1 ಅಂತ ಅಂದ್ರೆ ನೀವು ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಆ ಪೈಪ್ ಒನ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದು ಪೈಪ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಫಸ್ಟ್ ಇಲ್ಲಿ ಏರಿಯಾ A1 ಅಂತ ತಗೊಂತಾ ಇದೀನಿ, ಸೊ ಇಲ್ಲಿ ಏರಿಯಾ A2 ಅಂತ ತಗೊಂತಾ ಇದೀನಿ. V1 V2 ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನ್ ವೆಲಾಸಿಟಿ ಅದು V1 ಆಗುತ್ತೆ, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಏನ್ ವೆಲಾಸಿಟಿ ಅದು V2 ಆಗುತ್ತೆ. ಓಕೆ, ರೋ 1 ರೋ 2 ಅಂದ್ರೆ ಡೆನ್ಸಿಟಿ ಆಫ್ ದಟ್ ವಾಟ್ ಎವರ್ ದ ಲಿಕ್ವಿಡ್. ಆದ್ರೆ ನಾವ್ ಏನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ಆ ಪೈಪ್ ಅಲ್ಲಿ ವಾಟರ್, ಆಯಿಲ್ ಏನೇ ಇರ್ಲಿ, same liquid it is passing. How the, so when the same liquid is passing, the density will be same. Therefore the final equation becomes A1 V1 is equal to A2 V2. This is the equation of continuity. So this is called as equation of continuity. Then next we have the Bernoulli's theorem. So what is this Bernoulli's theorem? That is for an incompressible, non-viscous, irrotational liquid. ಅಂದ್ರೆ Bernoulli's theorem ನಾವು ಅಪ್ಲೈ ಮಾಡ್ಬೇಕಾದ್ರೆ ಈ 3 conditions ನಮಗೆ ಬೇಕಾಗುತ್ತೆ. The liquid must be incompressible, and the liquid must be non-viscous, and the liquid must be irrotational liquid having streamlined flow. So ನಮಗೆ ಗೊತ್ತಿದೆ turbulent flow ಮತ್ತೆ streamlined flow ಅಂತ ಕಲಿತೀವಿ. Bernoulli's theorem is applied only for the streamlined flow. The sum of the pressure energy, kinetic energy and potential energy per unit mass is constant. ಹೌದಾ? So this is Bernoulli's theorem. ನೀವು ಇಲ್ಲಿ equation ನೋಡಿ, ನಾವು ಇವತ್ತು ಇದ್ರ ಮೇಲೆ ಕ್ವೆಶ್ಚನ್ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದೀವಿ. So there is P by rho is pressure energy, V square by 2 is kinetic energy, GH is what? That is potential energy, is equal to constant. So this is Bernoulli's theorem. ಹೌದಾ? Next, viscosity. So this is the property of the liquid. So ಇದೇನಿದೆ ನೋಡಿ, viscosity ಅನ್ನೋದು property of the fluid or the liquid here, by virtue of which an internal frictional force comes into play when the fluid is in motion in the form of a layer. ಅಂತಂದ್ರೆ if you consider this as a pipe, ಇಲ್ಲಿ liquid ಏನಾದ್ರೂ flow ಆಗ್ತಾ ಇದ್ರೆ ಅದರಲ್ಲಿ different layers ಇರುತ್ತೆ. ಹೌದಾ? So different layers, in between the layers whatever the opposition will be there, that opposing force and the property is called as what? Viscosity. Opposing force is called as viscous force and the property is called as viscosity here. Okay, so this viscosity is also called as what? Fluid friction anta kuda ಹೇಳ್ತಾರೆ. So I told you, that is whatever the different layers are there, the force will be acting between them. That force is given by, so you can see the expression, force F is equal to minus eta A into dV by dx. Eta is the coefficient of viscosity. They will give the value. A is the area. Then dV by dx is the, it is a gradient, velocity gradient anta ಹೇಳ್ತಾರೆ. ಅಂದ್ರೆ velocity is changing. So sorry, the velocity along the length of the pipe is called as velocity gradient. So what is this negative sign? It shows that it is in opposing nature. ಹೌದಾ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಯಾವಾಗಲೂ ಏನಿರುತ್ತೆ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಗೆ ಅಪೋಸ್ ಆಗಿರುತ್ತೆ therefore the negative sign we can see. So coefficient of viscosity eta is there, so its definition you can see there. The equation can be rearranged as you can see this one, eta is equal to F divided by A into dV by dx. So the SI unit of coefficient of viscosity is, so you can see that the SI unit is, that is Poisson, right? Then here dimension formula is given by, that is m L raised to minus 1 T raised to minus 1. Then we have the Stokes law here. What is the Stokes law? The Stokes law, F is equal to 6 pi eta r v. Actually v kuda barutte, that is 6 pi eta r v. Okay, 6 pi is constant, eta is the coefficient of viscosity. Then next, r is the radius, v is the terminal velocity. So what is terminal velocity? You can see this. It is the maximum constant velocity acquired by the body while falling freely in a viscous medium. And this terminal velocity is given by. So idu formula kuda note down madಕೊಳ್ಳಿ. That is 2r square into bracket rho minus sigma into g divided by 9 eta. So r is the radius. Then eta is coefficient of viscosity. G is acceleration due to gravity. What is this rho and sigma? So rho and sigma is nothing but what? It is the density is here. Density nodi, that is rho is the density of the material, matte sigma is the density of the medium here. Okay, so here this is regarding the terminal velocity. Then next, so based on the expression here they have written directly proportional, inversely proportional and all, right? So this is terminal velocity is equal to formula. So terminal velocity is equal to, again take down the formula, that is pi rho r to the power 4 divided by 8 eta into L. So again, that is eta is coefficient of viscosity, L is the length, R is the radius. Then we have the Reynolds number. So what is this Reynolds number? This Reynolds is a number. It is idondu number ide, ಏನು ಹೇಳುತ್ತೆ ನಮಗೆ the flow of the liquid, whether it is streamline one or whether it is turbulent one. So streamline ಅಂತಂದ್ರೆ ಏನು? ನೀವು ಒಂದು ಪೈಪ್ ಅಲ್ಲಿ liquid flow ಆಗ್ತಾ ಇದ್ರೆ at each and every point the velocity will be same. The velocity is same, then it is called as streamline flow. If the velocity is different, then it is called as turbulent flow. Okay, so ಈ Reynolds number du value ide, right? Here you can see this one. The Reynolds number is having the value, that is if it is, that is less greater than 1000, it is called as streamline flow. Then if it is less than 2000, then it is turbulent flow. Okay, then here the question comes, if it is in between 1000 and 2000, what it is? So it is unsteady. We say that it is unsteady. Then we have the expression for Reynolds number also. You can see this expression. The Reynolds number is given by rho AV square upon eta AV upon D. So this is your Reynolds number. Okay. So last concept, that is critical velocity. What is critical velocity? The critical velocity is that velocity of liquid up to which its flow is streamlined and above which it is becoming turbulent. So idu critical velocity ಅನ್ನೋದೊಂದು velocity ಆಗುತ್ತೆ. So ಇದೇನಾಗುತ್ತೆ, ಆ velocity ಅನ್ನ ಮೀರಿದ್ರೆ the liquid is called as, it is in a turbulent motion. If it is below than that, then it is streamlined, right? Then we have the surface tension here. What do you mean by surface tension? Surface tension is nothing but what? This is the property of the liquid by virtue of which the free surface of liquid at rest tends to minimize the area. ಅಂತಂದ್ರೆ ನೀವು ಏನಾದ್ರೂ ಈಗ ವಾಟರ್ ಡ್ರಾಪ್ ಅನ್ನ ಬಿಟ್ರಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ ಸರ್ಫೇಸ್ ಮೇಲೆ. ಸೊ ಆ ವಾಟರ್ ಡ್ರಾಪ್ ಅನ್ನ ನೀವು ಬಿಟ್ರಿ ಒಂದು ಹೈಟ್ ಅಲ್ಲಿ, ಅದನ್ನ ಕೆಳಗಡೆ ಹಾಕಿದ್ರಿ ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ, ದಟ್ ವಾಟರ್ ವಿಲ್ ಟ್ರೈ ಟು ಅಕ್ವೈರ್ ದ ಮಿನಿಮಮ್ ಏರಿಯಾ. ಸೊ ಯಾಕದು ಆತರ ಮಾಡುತ್ತೆ? ಬಿಕಾಸ್ ಆಫ್ ದ ಪ್ರಾಪರ್ಟಿ ಕಾಲ್ಡ್ as what? Surface tension. Because of the property of surface tension. Then we have here angle of contact. So what is angle of contact? This is the nothing but the tangent. So ನೀವು ಏನಾದ್ರೂ ಇಲ್ಲಿ I'll show you, that is Okay, suppose if you consider this is one surface, ಇದು ಒಂದು solid surface ಇದೆ, ಇದ್ರ ಮೇಲೆ ಏನಾದ್ರೂ ಒಂದು water droplet ಅಥವಾ ಯಾವುದೋ ಒಂದು liquid drop ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. So here whatever the angle it is creating, this angle is called as angle of contact. It is the tangent drawn to the liquid surface at the point of contact which it makes with the solid. So this is called as angle of contact. So ಇದು angle of contact ಕೂಡ acute ಇರುತ್ತೆ, obtuse ಇರುತ್ತೆ. Based on the nature of the liquid we can say that is whether it is acute, obtuse, how the convex, concave surfaces ella form agutte idರಲ್ಲಿ. This is regarding the angle of contact, right? Yes. So next we will go for the question answers. Again in the question answers whatever it will come later, once again we can discuss that. Okay, ನಾನೀಗ question answers ಅನ್ನ ಡಿಸ್ಪ್ಲೇ ಮಾಡ್ತೀನಿ. So one more, if any points are left here, we will see in this slide. If any points are left, see here. Yes, so we have discussed about pressure, atmospheric pressure, then critical velocity, Reynolds number. Idu bere slide ide, matte enadru miss agidre navu illi nodabodu. Equation of continuity, AB is equal to constant. Hauda? Then Bernoulli's principle also we have discussed. Then illondide nodi, that is velocity of a flux. So velocity of a flux is given by, so ill nodi V is equal to under root of 2hg. So g is acceleration due to gravity, h is the height. ನೀವು ಇಲ್ಲಿ figure ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. Okay, I hope you are able to see this. This lesson is little tough it is, so you just go through the question formulas. I'll explain you concepts once again while solving the questions. Okay, so here the viscosity, viscous force, unit, dimension formula, Stokes law, terminal velocity. Na just nimge confirm ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Yes, so just now I told you about the angle of contact. So this is regarding the excess pressure. ಈಗ ನಾವೇನ್ ಮಾಡೋಣ, ಕ್ವಶನ್ ಆನ್ಸರ್ಸ್ ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಹೋಗೋಣ. ಮತ್ತೇನಾದ್ರೂ ಇದ್ರೆ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ, ಆಯ್ತಾ? So this is our first question for today's class, that is, if pressure at half the depth of a lake is equal to 2/3 pressure at the bottom of the lake, then what is the depth of the lake? So the pressure they are asking at the depth means h, right? So if it is possible you try, otherwise I'll tell you the solution. See ಏನಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ really, that is pressure they are asking you to calculate pressure. What they have given, the pressure is given as 2/3 of the pressure at the bottom. So I'll consider at the bottom the pressure as P dash, ಮತ್ತೆ pressure is equal to ನಾನು 2/3 P dash ಅಂತ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? That is, if you consider the lake at the bottom pressure is P dash, here the pressure at a depth they are asking. So pressure at the depth they are asking here, right? So then what is the depth of the lake. So H value they are asking you. How we can solve this? The solution is given by, so here it is visible, no? Question is visible, no? PPT.
Ma'am, PPT is visible, but question is not displaying, ma'am. Angle of contact, that description is displayed, ma'am.
Okay, then once again I'll share this PPT.
Okay, ma'am.
I think so now it is visible. Yes, now I'll start.
Yes, ma'am.
Okay, so if pressure at half the depth of a lake is equal to 2/3 pressure at the bottom of the lake, then what is the depth of the lake? So here the pressure of the lake is given, that too at the bottom. Bottom alli pressure ಎಷ್ಟಿದೆ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, ಮತ್ತೆ lake ದು depth ಎಷ್ಟಿದೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. So based on the height formula, now pressure at some height we have discussed that one. ಹೌದಾ? So ನಾನು ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ, pressure is equal to, ಅವ್ರು ಕೊಟ್ಟಿರೋ hint ಪ್ರಕಾರ I'll take that the pressure is P is equal to 2/3 P dash ಅಂತ ತಗೋತೀನಿ, ಆಯ್ತಾ? So according to the theory ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ, ಅದರಲ್ಲಿ ಅದ್ರ ಪ್ರಕಾರ ಇಲ್ಲಿ ತಗೊಳ್ಳೋಣ, that is P0 is the atmospheric pressure. ಯಾಕಂದ್ರೆ ಲೇಕ್ ಇದೆ, it is exposed to the atmosphere, ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿ atmospheric pressure ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. So it is P0 plus rho GH. ಹೌದಾ? So rho GH. So here H I'll consider it as at H by 2, right? Because first ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, if pressure at half of the depth of a lake is equal to, so half of the depth, ಪೂರ್ಣ lake ದ್ದು height h ಅಂತ ಇದ್ರೆ half of the depth ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ, h by 2 ಅಂತ ಆಗುತ್ತೆ, ಹೌದಾ? Which is equal to, so which is equal to, that is it is 2/3 of the pressure. So again that is your P0 plus rho GH. It is P0 plus rho GH. So simplify this equation. ನೀವು ಇದನ್ನ simplify ಮಾಡಿ, ಇದು 2 ಅದ, ಆಯ್ತಾ? ಇದು 2/3, ಇದು P0. So if you simplify this equation, what you are getting, check out. ಇಲ್ಲಿ ನೋಡಿ ಹೇಗೆ simplify ಮಾಡ್ತೀರಾ. You can take the same terms on the same side. We require H is equal to, can you try this? So 3 ಅನ್ನ cross multiply ಮಾಡ್ಕೊಳ್ಳಿ. What we can do, that is 3, I'll take this 3 P0 plus 3 rho GH by 2 is equal to, so this is 2 P0 plus rho GH. Yes students? So 3 P0 minus 2 P0 is P0, ಹೌದಾ? P0 is equal to, so P0 ಅಂತ ಬಂತು. P0 is equal to ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ rho GH ಇದೆ, ಮತ್ತೆ ಅದು ಈ ಕಡೆ ಬಂದಾಗ ಅದು -3/2 rho GH ಅಂತ ಆಯ್ತು. Anybody got the answer? Check how much you are getting. Density, water ಅದು ಲೇಕ್ ಇದೆ, ಹೌದಾ? ವಾಟರ್ ಡೆನ್ಸಿಟಿ ಎಷ್ಟಾಗುತ್ತೆ, 10 to the power of 3. Then acceleration due to gravity, you can take it as 10 ಅಂತ ತಗೊಳ್ಳಿ, ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಗೆ ಈಸಿ ಆಗುತ್ತೆ. Okay, see here I'll explain this answer once again. If pressure at depth of the lake is equal to 2/3 pressure at the bottom of the lake, ಹೌದಾ? ನೀವೇನಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ, that is if you consider this as lake, ಇದು just imagine ಮಾಡಿ ಇದು lake ಅಂತ, ಆಯ್ತಾ? At the half, whatever the pressure is there, ಇಲ್ಲಿ half of the lake ಏನ್ pressure ಇದೆ, that pressure is equal to 2/3 pressure at the bottom. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ಹಾಫ್ ಆಫ್ ದು ಲೇಕ್ ಏನ್ ಪ್ರೆಷರ್ ಅಂತ ಇದೆ ಅದನ್ನ ನಾನು P ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, at the bottom P dash ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ at the bottom ದ್ದು 2/3 of the pressure is there at the half of the liquid. ಇದಿಷ್ಟು ಅರ್ಥ ಆಯ್ತಾ? ಅವ್ರು ಏನ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಇದು ಫುಲ್ ಎಂಟೈರ್ ಲೇಕ್ ಅದ್ದು ಹೈಟ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಅವರು ಹೈಟ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಹೌದಾ? ಸೊ ದ ಗಿವನ್ ಡಾಟಾ ಐ ಹ್ಯಾವ್ ರಿಟನ್ ಹಿಯರ್, ದಟ್ ಇಸ್ P is equal to 2/3 P dash. Next, so here at the half of the distance, what is the pressure? That is P naught plus rho g H by 2. Atmospheric pressure concept ಅನ್ನು ನಾವು ತಗೋಬೇಕಾಗುತ್ತೆ. ಇಲ್ಲಿ ನಾನು ನಿಮಗೆ ಫಾರ್ಮುಲಾ ಈಗಷ್ಟೇ ತೋರಿಸಿದ್ದೆ, ಹೌದಾ? Right, next. So next here, so some students are getting option B, 20 meter, that is right. So see here, whoever did not get the solution, I am explaining you once again. As it is a lake, we need to consider atmospheric pressure also. Therefore, it is P naught plus rho g H by 2 is equal to 2/3 P naught plus rho g H. So I hope whatever I am explaining you this step, it is clear to you. Artha aita? Some student asked this solution once again. Kanchana Raj, I hope it is clear now. You are understanding this? Yes. So try to simplify this. Okay. So ಅದೇ simplification ನಾ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇಲ್ಲಿ 3 ಅನ್ನ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡೆ, that is 3 P naught plus 3 rho H by 2 is equal to 2 P naught plus rho GH. So P naught is equal to, so P naught is equal to ಈ equation ಬಂತು. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, rho G ಕಾಮನ್ ಆಗಿ ತಗೋಬಹುದು ನೀವು. ರೋ ಮತ್ತೆ ರೋ ಎಷ್ಟಾಗುತ್ತೆ, ವಾಟರ್ ಡೆನ್ಸಿಟಿ is 10⁻³ acceleration due to gravity, take it as 10, right? So solution you can take it like this. This is equal to 10⁻³, 10 is nothing but 10⁻⁴. Inside the bracket H minus 3/2 into H. They are asking you to calculate H value. They are asking you to calculate H value. Okay. So 20 meter we are getting. I hope everybody got the answer. So many are replying it as option B. So 20 meter is the answer. Okay. So I'll go to the next question. Yes, the next question is, two bodies are in equilibrium when suspended in water. So two bodies ide A and B anta, ನೀವು ಅದನ್ನ ವಾಟರ್ ಅಲ್ಲಿ ಸಸ್ಪೆಂಡ್ ಮಾಡ್ತೀರಾ from the arms of a balance. ಅಂತಂದ್ರೆ ಒಂದು ಬ್ಯಾಲೆನ್ಸ್ ಇದೆ. So from that balance, so if you consider this as a balance, from this balance you are suspending two masses in water. The mass of one body is 36 gram. So one body mass ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಾರೆ, 36 gram, and its density is 9 gram per centimeter cube. ಆಯ್ತಾ, one side body mass 36 gram ಮತ್ತೆ density 9 gram per centimeter cube. If the mass of the other body, so ಎರಡು ಬಾಡಿ ಇದೆ, ಅದ್ರಲ್ಲಿ ಮತ್ತೊಂದು ಬಾಡಿ ಮಾಸ್ 48 gram ಇದೆ, ಅದ್ರ ಡೆನ್ಸಿಟಿ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಅವರು, ಹೌದಾ? How we can do this? So is the solution. Okay, so that is mass and density is given for one body. For second body they are asking you the density value. How we can do this? Here the solution is given by, that is apparent weight is equal to, that is apparent weight is equal to, that is V into bracket rho minus sigma into G, rho minus sigma into G. ಆಯ್ತಾ? So V is volume here. V ಅಂತಂದ್ರೆ ವಾಲ್ಯೂಮ್ ಆಗುತ್ತೆ. So ನಮಗೆ ಕ್ವಶನ್ ಅಲ್ಲಿ ಡೆನ್ಸಿಟಿ ಕೊಟ್ಟಿದ್ದಾರೆ. So in terms of density, V can be written as, it is nothing but mass upon density into bracket rho minus sigma into G. Right? So now you can substitute the value. So that is what rho is the density here. ಆಯ್ತಾ? So for two bodies it is given, they are in equilibrium. Equilibrium ಅಂತಂದ್ರೆ ನಾವ್ ಏನ್ ಮಾಡ್ಬೋದು, ಎರಡದ್ರದ್ದು ಏನ್ ಇಕ್ವೇಶನ್ ಇದೆ ನಾವು ಅದನ್ನ ಈಕ್ವೇಟ್ ಮಾಡ್ಬೋದಾಗತ್ತೆ. So I'll take the formula as m1 upon rho 1 into bracket rho 1 minus sigma into G is equal to m2 upon rho 2 into bracket rho 2 minus sigma into G. So G, acceleration due to gravity. How that it is same on both the side, you can cancel that. Then sigma, that is the density of the medium. Water allee now suspend ಮಾಡ್ತಾ ಇದೀವಿ, right? So whatever the bodies are there, water ಅಲ್ಲಿ suspend ಮಾಡೋದ್ರಿಂದ ಅದು density ಕೂಡ sigma value cancel ಆಗುತ್ತೆ. So you are left with only 36/9 is equal to 48 by rho 2. Rho 2 value ಬೇಕು ನೋಡಿ ನಮಗೆ. Option C, Nisarga. Yes, it is right. Yes, Kanchana, very good. Yes, remaining students try ಮಾಡಿ. Option 3C ಬರುತ್ತೆ. So ಇಲ್ಲಿ ನೋಡಿ m1 ಅಂತಂದ್ರೆ ತಗೊಳ್ಳೋಣ, ವ್ಯಾಲ್ಯೂಸ್ ತಗೊಳ್ಳೋಣ ಈಗ. That is 36 divided by 9 into bracket 9. So ಬಾಕಿದೆಲ್ಲ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ ಆಯ್ತಾ. ಸೊ ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಲ್ಲ ಮತ್ತೆ. ಸೊ ಇಲ್ಲಿ 48 divided by rho 2 into bracket rho 2 minus 1. Sorry, here 9 minus 1. ಅದು ನಾವೇನದು ಸಿಗ್ಮಾ ಇದೆ ಅದನ್ನ ನಾವು 1 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ ಆಯ್ತಾ. That is density of water. So if you simplify, the value of rho 2 will be, it is 3. Option C is the correct option. Simplify this one. Rho 2 you require. 9 minus 1 is 8. 8 into 36 divided by 9. One side ಆಗತ್ತೆ. ಮತ್ತೊಂದು ಕಡೆ rho 2 ಇದೆ, ಅದನ್ನ ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬೇಕಾಗುತ್ತೆ. Others are also getting the answer. It is option C. 3 is the answer, C. Simplify this, you will get the answer. Okay, let us go to the next question. I hope the PPT is visible to you. The next question is, okay, we have the next question here, that is an inverted bell lying at the bottom of a lake. So an inverted bell lying at the bottom of a lake, 47.6 meter deep, has 50 centimeter cube of air trapped in it. How the an inverted bell lying at the bottom of a lake, bottom of the lake alli, whatever that bell is there, that is having the length as 47.6 meter. Deep has, that is 50 centimeter cube of air trapped in it. So adralli air molecule ide, adrad ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು, ವಾಲ್ಯೂಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ 50 cm cube. ಹೌದಾ? The bell is brought to the surface of the lake. The bell is brought to the surface of the lake. The volume of the trapped air will be, the volume of the trapped air will be. So let us see how to solve this one. They have given the atmospheric pressure. ಇಲ್ಲಿ atmospheric pressure ಕೊಟ್ಟಿದ್ದಾರೆ, that is 70 centimeter of Hg. 70 centimeter of Hg. Then density of the mercury is also given, that is 13.6. It is given as 13.6. So let us solve this one. Okay. So first, that is pressure and volume. What is the relation that we need to see? So if you see the equation, the pressure and the volume are inversely proportional to each other. Yav law prakara? Boyle's law prakara. You have studied already. The Boyle's law is pressure is inversely proportional to the volume, right? So therefore, so what I'll do, I'll write the equation here. So the equation I'll take it as V2 is equal to 1 plus H rho G into W divided by P naught. So whole into bracket V1. So with this equation, we are going to simplify this, okay? The volume of the trap. So volume ಕೇಳ್ತಾ ಇದ್ದಾರೆ ನಮಗೆ ಪ್ರೆಷರ್ ಮತ್ತೆ ವಾಲ್ಯೂಮ್ ರಿಲೇಷನ್ ಗೊತ್ತಿದೆ pressure and volume are inversely proportional to each other, right? So whatever the equation is there ಅದರ reciprocal ಆಗುತ್ತೆ pressure ಏನ್ equation ಇದೆ ಅದರದ್ದು reciprocal ಇಲ್ಲಿ volume equation ಆಗಿ consider ಮಾಡ್ತೀವಿ, that is V2 is equal to 1 plus rho gh W upon P naught into V1. So substitute all the values here. So if I substitute, that is V2 is equal to, it is 1 plus, V2 is equal to, it is 1 plus, yes, Harshita, it is 300, correct. Okay. So remaining students solve it, that is 1 plus, substitute other values, that is H value. 47.6. So everything is given, just substitute the value. 47.6 into 10 raised to 2, next, into 1000 divided by 47.6 into 10 raised to 2 into 1000 into 1, okay, divided by, that is P naught, atmospheric pressure. How much they are saying? 70 centimeter of Hg, 70 centimeter of Hg. So the 70 centimeter of Hg in terms of SI unit. Then the next question. So the next question is, a uniformly tapping vessel is filled with a liquid of density. So a uniformly tapping vessel is filled with a liquid of density 900 kg per meter cube. The force that acts on the base, of the vessel due to the liquid is. So here the force that acts on the base of the vessel they are asking. So let us calculate this. Okay. Try this one. P is equal to, so P is equal to, you can try it as, that is rho gh. So substitute all the values they have given. Density kottidare 900 anta ide, right? Acceleration due to gravity is also given. Then from the figure h, because we know that namge en bekagide, force is equal to, sorry, pressure is equal to force by area. Namge force bekagide. So from the figure you can see area value and you can calculate. Anybody is getting the answer? Yes, Harshita. It is 7.2 Newton. So see here students, ನೀವು ಇಲ್ಲಿ first pressure calculate ಮಾಡ್ಕೊಳ್ಳಿ. Pressure calculate ಮಾಡಿದ್ರೆ ನೀವು ಇಲ್ಲಿ substitute ಮಾಡಬಹುದು, ಆಯ್ತಾ? ನಮಗೆ force ಬೇಕಾಗಿದೆ, F is equal to. ಫೋರ್ಸ್ ಬೇಕಂತಂದ್ರೆ ಪ್ರೆಷರ್ ಮತ್ತೆ ಏರಿಯಾ ನಮ್ಗೆ ಬೇಕಾಗುತ್ತೆ ಇಲ್ಲಿ. ಸೊ ಪ್ರೆಷರ್ ಅನ್ನ ನಾವು ರೋ ಜಿ ಎಚ್ ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಡೆನ್ಸಿಟಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಎಕ್ಸಲರೇಷನ್ ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ ಇದೆ, height 0.4 ಅಂತ ಇದೆ. So you can substitute all the values. Any other students getting the answer? Anybody else? It is 7.2. Area is given. ನೀವು ನೋಡಿ ಅಲ್ಲಿ ಫಿಗರ್ ಅಲ್ಲಿ ನೋಡಬಹುದು ಏರಿಯಾ ಇದೆ ಹೌದಾ, 2 into 10 raised to minus 3. ಬೇಸ್ ಅಲ್ಲಿ ಕೇಳ್ತಾ ಇದ್ದಾರೆ, ಅವರಲ್ಲಿ ಎರಡು ಏರಿಯಾ ಕೊಟ್ಟಿದ್ದಾರೆ, ಒಂದು 10 raised to minus 3 ಅಂತ, ಒಂದು 2 into 10 raised to minus 3 ಅಂತ. ಸೊ ನೀವೇನ್ ಮಾಡಿ, ಬೇಸ್ ಅಂತ ಅಂದ್ರೆ ಕೆಳಗಡೆ ತಗೋಬೇಕಾಗತ್ತೆ ನಾವು ಏರಿಯಾ. ಎನಿಬಡಿ ಎಲ್ಸ್ ಗೆಟಿಂಗ್ ದ ಆನ್ಸರ್? ಇಟ್ ಇಸ್ 7.2 ನ್ಯೂಟನ್. ಮತ್ತೆ ಯಾರಿಗಾದ್ರು ಬಂತ? ಪ್ರೆಷರ್ ಇದು 3.6 into 10 raised to 3 ಅಂತ ಬರುತ್ತೆ. ಪ್ರೆಷರ್ ವ್ಯಾಲ್ಯೂ 3.6 into 10 raised to 3. Yes, B. Okay, let us go to the next question. Okay, see here, a siphon in use is demonstrated in the following figure. A siphon in use is demonstrated in the following figure. So you can see the figure. The density of the liquid flowing in siphon is, so density is given, that is 1.5 gram per centimeter cc, right? The pressure difference between the point P and S will be, so see here, pressure at the point P and S. So in the figure, the P and S. Yes, very good. It is 0. It is option C, 0. So why it is 0? So what is happening here? That is, as both points are at the surface of the liquid. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಎರಡು ಪಾಯಿಂಟ್ ಸರ್ಫೇಸ್ ಆಫ್ ದ ಲಿಕ್ವಿಡ್ ಇದೆ ಹೌದಾ, at the surface of the liquid, right? So which is open to the atmosphere, which is open to the atmosphere. Therefore whatever the pressure is there, that will be equal to 1 atmosphere ಹೌದಾ, that will be equal to 1 atmosphere ಆಗುತ್ತೆ. So pressure difference ಅಂದಾಗ 1 minus 1 ಅಂತಂದ್ರೆ ಎಷ್ಟು ಬಂತು, 0 ಅಂತ ಬರುತ್ತೆ ಹೌದಾ. Therefore option C is the correct one here. Okay, yes. Then next question, that is the height of a mercury. The height of a mercury barometer is 75 centimeter at sea level and 50 centimeter at the top of a hill. Ratio of density of mercury to that of air is 10 to the power 4. The height of the hill is, the height of the hill is. Okay, so how to do this? So first you take down the data what they are giving you. The height of the mercury barometer is 75 centimeter. ಒಂದು H1 ಅಂತ consider ಮಾಡಿ, 75 ಅಂತ ಇದೆ. H2 is 50 centimeter. Yes, correct. It is 2.5. Answer is 2.5 kilometer. Yes, very good, Harshita. Then next, see, H1 is 75, H2 is 50 centimeter. ಹೌದಾ, ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀರಾ? The formula is the difference in the pressure is given by, that is delta P is equal to H1 minus H2 into, that is P of mercury into acceleration due to gravity. So this is 75 minus 50 into P of Hg is 10 raised to minus 2. Okay, into, that is rho gh. This is my equation 1. This is my equation 1. Okay, so let us write equation 2. That equation 2 is given by delta P is equal to H into P of air. So illi P of mercury anta bantu, illi P of air anta barutte hauda. So P of air, this is P of mercury into G as it is. I just substituted the value. This is into air into acceleration due to gravity. This is our equation 2. This is our equation 2 here. So equation 1 is what? 75 minus 50 into 10 raised to minus 2. ಹೌದಾ, ಯಾಕಂದ್ರೆ ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಇದೆ, ಮೀಟರ್ ಅಲ್ಲಿ ತಗೋಬೇಕಾದ್ರೆ 10 raised to minus 2 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಎಸ್. ನೆಕ್ಸ್ಟ್ P of mercury I am keeping as it is, G I am keeping as it is. ಮತ್ತೊಂದು equation ಬರ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ for air, that is delta P is equal to H into P of air into G. This is my equation 2. So equation 1 ಮತ್ತೆ 2 ಅನ್ನ equate ಮಾಡಿ. Both, so equation 1 ಮತ್ತೆ 2 ಅನ್ನ equate ಮಾಡಿ. So if you equate equation 1 and 2, I'll show you the last step here. That is P is equal to, we will get it as 25 into 10 raised to minus 2 into bracket P of mercury upon P of air, right? So this is equal to 25 into 10 raised to minus 2. This is nothing but they are giving you ratio in the question. This is 10 raised to 4. Okay. So ಮತ್ತೆ ಯಾರ್ಯಾರಿದ್ದೀರಾ? I hope you are understanding the solution here. Equate equation 1 and 2. So ಇದು ಡೆಲ್ಟಾ P ಅಂತ ಇದೆ, ಇದು ಡೆಲ್ಟಾ P ಅಂತ ಇದೆ. ಇದನ್ನ equate ಮಾಡ್ಕೊಳ್ಳಿ. ಇದನ್ನ equate ಮಾಡಿದಾಗ ನಿಮಗೆ ಈ ತರ ಬರುತ್ತೆ. P is equal to 25 into 10 raised to minus 2 P of mercury upon P of air. P of mercury upon P of air value na ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರಲ್ಲಿ. So substitute, you will get P is equal to option B. That is 2.5 kilometer. Okay. Yes. Let us go to the next question. Next question. Density of ice is rho and that of water is sigma. Density of ice is rho and that of water is sigma. What will be the decrease in volume when a mass capital M of ice melts? So mass they are asking you here. They are asking you to calculate the mass. So this is little simple here. So mechanical properties of fluids. ಸ್ವಲ್ಪ concepts ಎಲ್ಲ tough ಇದೆ ಇಲ್ಲಿ, ಆಯ್ತಾ? So now ಇಲ್ಲಿ solution ಮಾಡೋಣ. That is, so somebody got the answer, I think. It is option C or D. You check it. C ಬರುತ್ತಾ D ಬರುತ್ತಾ check ಮಾಡಿ. C you are getting or D you are getting. Okay, so how we are going to solve this? That is volume of the ice. That is volume of ice is equal to, that is mass upon density. So mass upon density. Volume of ice ಅನ್ನ ಏನಂತ, density ಏನಂತ ತಗೋತಿದ್ದಾರೆ? Rho ಅಂತ ತಗೊಂತಾ ಇದ್ದಾರಾ? ಹೌದಾ? So ನಾ rho ಅಂತ ತಗೋತೀನಿ ಇಲ್ಲಿ. Next ನಮ್ದು ಏನಿದೆ? Volume of water. So volume of water ಅಲ್ಲಿ m divided by again density, that is given by m divided by sigma, right? So decrease in volume they are asking. So the decrease in volume is equal to, that is volume of ice minus volume of water. ಹೌದಾ? So ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ? Mass is common in both the equations. So in the inside the bracket it is 1 by rho minus 1 divided by sigma. It is 1 by rho minus 1 divided by sigma. Yes. So option C is correct here. Howda? Yes, option C is the correct one. So 2-3 students got the answer. That is option C. It is right. Okay. Let us go for the next question. Okay, the next question is equal masses of water and a liquid of density. Equal masses of water and liquid of density. Two are mixed together. Then the mixture has a density of. So the mixture density ಕೇಳ್ತಾ ಇದ್ದಾರೆ. So water ಮತ್ತೆ liquid ಇದೆ. ಅದು ಬೇರೆ ಬೇರೆ densities ಅಲ್ಲಿ ಇದೆ. They are mixed. So mix ಮಾಡಿದಾಗ ಅದೇನ್ mixture form ಆಗತ್ತೆ, ಅದ್ರದ್ದು ಏನ್ density ಬರುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ. So let us see how to do this. That is given by Okay. So if anybody is okay, so we have very clever students. They are getting answer very quick here. So 4/3 anta ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ನೋಡೋಣ 4/3 it is right actually. Okay, so how to solve this? See, remaining students, that is, let the volume of the water is V. So density is equal to ಏನ್ ಬರುತ್ತೆ, mass by volume ಅಂತ ಬರುತ್ತೆ. ನಾನು ಇದನ್ನ equation 1 ಅಂತ consider ಮಾಡ್ತೀನಿ. Okay, since the water liquid density is 2, ಹೌದಾ, ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು, density of the liquid is 2 are mixed, that is given by volume is equal to total mass. So total mass ಎಷ್ಟಾಗುತ್ತೆ, we don't know what is the actual mass, therefore m plus m I'll consider it as 2m. Total volume I'll consider, so total volume is nothing but v plus v by 2. So this is equal to 3v by 2 anta aitu, hauda. Therefore the density is equal to mass upon volume. Therefore mass is how much, it is 2m, and volume is how much, it is 3v by 2. So if I simplify this, we will get it as 4m upon 3v. So this m by v is nothing but equation 1. How the 4/3? Option B is right. Option B is right here. Yes. So many students are getting the answer here. Okay. So let us go for the next question. Okay. A body of density. No, this is not covered. No, yes. So we can do this. That is, a body of density D1 is counterpoised by mg of weights of density D2 in air of density D. Then the true mass of the body is. So here they are asking you the true mass of the body. So what they are giving, the density of the body is D1. How the students are getting answer very quick. Already you people have this question, or what be till I display you are getting the answers. Question ಮೊದಲೇ ಇದೆ ನಿಮ್ಮ ಹತ್ರ. It is option D, correct it is. So how to do this? Remaining students, you are getting the answers. It is option D. Can you try it based on the previous concept so that we can go for the next question? Yes. Okay. So I'll go to the next question. So our next question is, see here, that is, the pressure at the bottom of a tank containing, the pressure at the bottom of the tank containing a liquid does not depend on, it does not depend on. So that is acceleration due to gravity, height, area, nature of the liquid. See. Sure? Yes. Okay, see here, the pressure and the at the bottom of a tank containing liquid, it does not depend on. Namdu pressure is equal to expression enide, pressure is equal to rho gh, pressure is equal to rho gh. So rho andre density, hauda, g andre acceleration due to gravity, h andre height, right? So density ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ, nature of the liquid ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. height ಕೂಡ ಇದೆ, acceleration due to gravity ಇದೆ. ನಮ್ದು pressure expression ಅಲ್ಲಿ area ಬರಲ್ಲ, therefore we can say that it is independent. Yes, very good. So here it does not depend on the area of the bottom surface. Okay. So last one more question we will discuss for the today's class. One more question for. So see here again theory it is, that is, in which of the following cases, in which of the following cases will the liquid flow in a pipe be most streamlined? So here Reynolds number ಮತ್ತೆ viscosity relation ಗೊತ್ತಾದ್ರೆ ನೀವು ಇದರ ಆನ್ಸರ್ ಹೇಳ್ಬಹುದು. So I'll just tell you the relation, you just see and you can tell by yourself. Viscosity, sorry, Reynolds number is proportional to R into rho upon eta. So now eagaste nodidvi idanna. So they are inversely proportional. Howda? So in which of the following case it is most streamlined one? So if the Reynolds number is less, Reynolds number less ಆಗ್ಬೇಕಂತಂದ್ರೆ ಇದ್ರಲ್ಲಿ ಯಾವ condition satisfy ಆಗುತ್ತೆ? A, B, C, D. Let us see what students are telling. It is B. Yes, very good. So it is B. ಹೌದಾ? ನಾನು ಇಲ್ಲಿ ಫಾರ್ಮುಲಾ ಕೊಟ್ಟಿದ್ದೀನಿ. Reynolds number is directly proportional to radius and density and it is inversely proportional to viscosity. So B is what? Liquid of high viscosity. So high viscosity ಆದ್ರೆ ಏನಾಗುತ್ತೆ? Reynolds number ಕಡಿಮೆ ಆಗುತ್ತೆ. ಹೌದಾ? So automatically the option B is the correct one here. So for further questions we will discuss in the next class. I hope the concepts are clear to you. So once again you revise it, go through the video. Okay. So tomorrow we will meet. Thank you students. Thank you. Have a good day.